chapter 3 is on polynomials. And you've done this before. I don't know how much of the language you know, so I'm going to kind of test it here. If I write this down, 4x cubed, and I call that a monomial, but if I write this down, 4x cubed minus 8x squared, what would I call that? Okay, I thought you knew this. What I'm doing is I'm counting the number of, they're called terms. You guys know what terms are? Terms are added together. Terms are added together. You can't see that. So that's a binomial right now, right? I'm going to add one more term to it. I'm going to write minus 11x, and now it is a trinomial, okay? I'm going to add one more term to it, put a minus 3, then I kind of run out of names. I mean, we don't call it a quadrinomial or anything like that. It's just a polynomial at this time, right? Poly means many terms, okay? And so I can think of this as an object in an algebra class, but now what I want to do is I want to think of it as a function. That's kind of new. So I'm going to call this function g of x. G of x is 4x cubed minus 8x squared minus 11x minus 3. Okay? If I said to you guys, I want to graph that, what would you tell me? What? You say no. That's absolutely right. You should. You should say, how would I graph it? I'll tell you how I'm going to graph it. Right? You guys use these on the take-home exam last night? Absolutely, right? I mean, this makes it a lot easier. It'll do a whole bunch of inputs and outputs and sketch a graph for me. But let's put it away for a minute, because I'm trying to learn algebra, and sometimes it helps to put the technology down. Let me ask you this. Could I do it with transformations? I don't know. I guess it would depend if you know kind of the basic function that I'm talking about. The generic function. Kind of like the starting point. And this is not easy. This is not easy. Anyone know what I would use as kind of a starting point? The base function here? Well, how about this one? F of x is x cubed. Do you guys know what that looks like yet? Some people did. I remember I asked this the day before the test. I didn't ask this on the test. I said, that's not, we'll get to that in chapter 3. I did ask about this function on the test. I'm going to bring this one up again. I called it, what did I call it? I called it, I'll do it in green. I called it R of P. Remember this one? What was it? Negative 4p squared, right? And then plus what? Plus 4,000p. And I did at one point ask you to sketch a graph of that thing. Do you know what shape it is? You should know this one. This we covered. What is it? It's a parabola, right? This is in what the book called the general form. Okay? And I told you guys put it in standard form. And the reason I did that is I wanted you to be able to graph it. Okay? You want me to walk through that real quick for you? Okay. So what do we do? Well, remember that what we did was we factored out what? Negative 4. And so I have, what do I have? Let's see, p squared. And then I have, it'd be minus 1,000p. You guys with me so far? Okay. And now I need to figure out what goes there. right? Because I need to do what's called, yeah, that's kind of complicated, completing the square. The idea is that I hope I'll be able to write r of p equals negative 4 times something squared, like that, times what kind of polynomial? When I add something here, I'm going to have a trinomial, and I hope that it factors into what squared? A binomial, that's right. Do you guys see what we're talking about? So, well, I know it's going to have to be p, because I got to get p squared there. And I know it's going to have to be minus, and I guess the question is, do you know what I should add? Yeah, let's see. Right. So first of all, what goes here in the pink? Well, let me write that. Let's see. This equals negative 4 p squared minus 1000p. Now, what do I put there? Well, what goes there is half of what? Negative 1000 squared. That's right. And of means times, so it's 1/2 times negative 1000 over 1 squared. So it's negative 500 squared. You know, some of you might have been mad at me for not having a calculator at this point. But you could square that. What's 5 times 5? And now I just need to know how many zeros to add on. So it's 250,000. Okay? Now if you're mad at me, okay, you're mad at me. Plus 250,000 goes here. Okay? But what did I really add? Well, let's talk about that. I really added what? I really added negative 4 times 250,000. So what did I really add? I really added negative 1 million. Does this make sense? Okay? So I really added negative 1 million, which means, what do I have to write? When I write that plus 250,000, I really added negative 1 million. If I don't want to change it, I have to write plus 1 million. Okay? Thank you. So the final answer, I guess, I'm going to have a plus 1 million here. Okay? And what goes in here now? Ooh, what goes there? Do you know? Yeah, that's where the negative 500, we should put a 500 there. It's half of the coefficient. And if you square 500, of course, you would get that 250,000. Okay? So if you understood that, then we know the vertex. The vertex is what? 500, 1 million. Okay? And what do these things stand for? What does P stand for? P was the what? Price of a dryer? 500 bucks. If they price the dryer at 500 bucks, then what happens? They make $1 million they'll be millionaires. $1 million in revenue. Okay? Yeah, before costs and everything else, right? This is just revenue. Profit, who knows? All right? But that's kind of nice to be able to figure out. It's a nice application. Okay, there was something else I asked you guys to do on the test, and that was to find the zeros of this function. What does that mean? It means figure out when's the revenue going to be 0, right? And so I'm going to solve the equation. I'll put a 0 into the equation equal to negative 4p squared plus 4,000p. Okay? How do you find the zeros of an equation like this? What'd you guys do? How do you find them? Yeah. I did that. So I have this equation. Then what? Oh. Is that what you did? Okay. But if you did this much, you're getting partial credit. You guys understand that? You're showing me you know what to do. But do you guys know how to solve this equation? I guess that's the question. Well, that's the key, is that you can do what's called factoring. Okay? If we have an equation equal to 0, and if we can factor, we're in good shape. So you're telling me you could take out negative 4p. So that's a nice way to write the function, right? Here, let me rewrite r of p this way. R of p is actually equal to, look at all these different ways I wrote it. I'll show you in a minute. First of all, let's finish. Negative 4p times what? Actually, it'd have to be minus, wouldn't it? P, because I'm taking out the negative. There's the negative. So it'd be p minus what? 1,000. Negative 4p times p minus 1,000. Okay? So guys, I want to sketch a graph now. I think I can. See, as soon as I have this equation written like this, I know what the zeros are. So if I'm going to sketch a graph, what do I know it goes through? Oh, you don't see it? I want to explain this so you understand it, guys. Look. See, if I have the equation negative 4p times p minus 1,000 equals 0, where it's factored, I know that one of the factors has to be 0. Either the negative 4p is 0, or what else could be 0? P minus 1,000 might be 0, right? If negative 4p is 0, what does that mean? P equals 0. If p minus 1,000 equals 0, what does that mean? P equals 1,000. Now, let me go back to what's going on here. This is the p-axis instead of the x-axis, because that's the input, is price. And the output is what? Revenue. So I have price in dollars and I have revenue in dollars. And what I just learned, oh, and this was part of the question too. I said, can you interpret it for me? Well, one of the points we get is when p is 0, we have r is 0. Right? This is r. So that's the point 0, 0. How do you interpret that? Well, if the price is 0, what does that mean? If you're giving them away, I'm sorry, you're not going to make any revenue. Right? Okay. If you start charging more, you'll make more revenue. To a certain point. There comes a point where you charge too much, you won't make any revenue. As a matter of fact, if I charge $1,000 for a dryer, according to this, that's on the graph, I'll make no revenue. Does that make sense to you guys? Why would I make no revenue? No one will buy it. How come? You can go down the street and get a $400 dryer or a $500 dryer, right? So of course no one's going to buy it if you charge $1,000. It's not worth it. Are you with me? And this is a decision a business person has to make is, hey, how much am I going to charge for this dryer? Well, don't give it away, but don't charge too much. Is there an ideal amount? Well, according to this model, what's the ideal amount to charge? Now, how do I know that? Well, it wasn't from this equation. It was from this form of the equation, which we called the general form of a quadratic. Right? You can read right off of there that one of the points is, what point would I write? Somewhere up here is 500, comma, 1 million. Okay? And we know it's a parabola, so that's the maximum point. All right, so it really does look like this. Now I have more to say still. I have more to say. Could you have solved this equation a different way right here when we were finding the zeros? How else could you solve it? Quadratic what? Formula. You guys remember that formula? P equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know we covered that on the very beginning of the year, that packet. All right? You could do this as long as you know what A, B, and C are. Okay? So what's A, what's B, and what's C? Well, let's see. A would be what? Negative 4. B would be 4,000. And C would be 0. All right? So think about what that does to my picture here. My formula, when I plug those in, I'm going to get P equals, where it says negative B, I would write negative 4,000 plus or minus the square root of what? Well, whatever 4,000 squared is, I'm not going to figure that out right now. I don't have a calculator. Minus what? It's going to be 0. Do you see that? Why is it going to be 0? Yeah. Hey, by the way, I'm surprised you guys aren't writing this down. I am. I am taking a video, so you can look at it later, but you will learn if you take notes. All over 2 times what? Negative 4, right? There's a lot of you that are writing it down, I noticed too. So let's see. P equals, well, what happens? Let's simplify. I get negative 4,000 over negative 8 plus or minus the square root of 4,000 squared over negative 8. You notice I just split that up into 2 fractions, and I have this plus or minus here. The reason I did that, I'm trying to make a point here that something happens in this problem. You get 2 solutions, one from the plus and one from the what? The minus. So let's see, I get P equals 40 divided by 8 is 5. So this is 500 plus or minus. Now what's the square root of 4,000 squared? 4,000 over negative 8. So you know what you get? You get P equals 500 plus or minus negative 500. Okay. What are the 2 answers you get? Well, you get either 0 or 1,000. 0 or 1,000. And so you can get it that way. But one nice thing about using this quadratic formula is that you learn something. You learn that you get 2 solutions to a quadratic equation, and it's always this. It's always the negative b over 2a plus or minus stuff. Okay? On the picture, where's negative b over 2a? Well, negative b over 2a is 500, right? That's right here. This is x equals negative b over 2a. And I had a number of you on the homework saying, you know, I don't like completing the square. I just like doing what the book does. I get negative b over 2a. And that's fine. If I do that, that's going to give me the x-coordinate of the what? Of the vertex. That's kind of nice. And then I can get the y-coordinate from it. Okay? So, a couple ways to do this. But the last thing to point out about this problem before we put it away is that there are 3 different forms of the same equation in these 3 rectangles. and they're useful for different things. Okay? The first equation up here, when I write it this way, I can see it's a polynomial. What kind of polynomial is this one? I guess it's a binomial. You guys with me? So that says that's what I'm studying. I want to study that in this chapter. This equation was useful because, actually, this was probably the most useful for graphing because it showed me the vertex, and I see transformations. I see I'm sliding 500 to the right, 1,000,000 up, and I'm flipping it. That's why it opens downward. And that's vertical scaling by 4 also. So I like this form also. We called that the general form of the quadratic. But I want to point out this form down here. What would you call this form? Well, I would call it factored form. And factored form shows me all of the what? And I know you guys probably did some factored form. You did factoring. Matter of fact, Math 0950 here at Lakeland, we teach factoring. We spend a long time. I just gave an exam on it. It's hard. It is hard to factor. Even coming up with this, well, that's not as bad as a lot of things because you could see the P was common. And so if you took that out, you're okay. But here, I don't have a greatest common factor for G. All right? By the way, I don't know if I've given you this lesson yet, but it's always good to do. Do you guys know what HTTP means? It means you're on a website. Yes. I mean, hypertext transfer protocol, but who cares, right? It means I'm on a web page if I see that. You guys with me? Okay. Do you know what this means when they have an S there? Secure. Is that important? What's it mean? Yeah? Yeah. How many of you bought something on the internet recently? A lot of people do, right? How do you do it? You type your credit card number in. You guys know how the internet works? Basically, everyone hooked up their computers to each other. So I send my credit card number through 30 perfect strangers' computers until it gets to California where I want to make my purchase. And then they say, okay, thanks. Not smart, right? Do you guys know how it works? That they can't see my credit card number? Well, it's not magic. It's mathematics. Okay, so again, the reason the internet's secure is because I take the credit card number and I multiply by some huge prime number. So what I'm going to do here is tell you that, hey, I have 221, right? And I want to show that I can find the credit card number. And I'm telling you a hint. Hint. I multiplied by 13. If you have that hint, now the person over at Amazon has that hint, let's say, they can get my credit card number. So what happens here? We do 13 into 221, right? So what do I do? 1. 1 times 13 is 13. I subtract. I get a 9. I get a 1. And then what do I do? What's that? Yeah. Do you know that? Me neither. 7? Basically what I do is I see how many times 1 goes into 9. I'll try 9. That doesn't work. I'll try 8. That doesn't work. Because if I put an 8 there and I multiply, I get something bigger. You guys with me? I put a 7 there, what happens? 7 times 13? And what happened? What does that tell me when I get a remainder of 0? It means that 221 is equal to 13 times 17, and that's the magic number I was going for, right? If you take a credit card number and multiply it by a very large prime number, you get something that is hard to factor. Even a computer trying every combination it could, it would take hundreds of thousands of years for it to guess it. And that's why the Internet's secure. It's not that it couldn't do it, it's that there's not enough time. You guys follow? So, similarly, I gave you guys a function today that I want to be able to find the zeros. F of x equals, well, let's see, it's 4x cubed minus 8x squared minus 11x minus 3. And I'd really like to factor that so that I can find the zeros. But it's very difficult, all right? So on the first day of homework, guys, we're not going to do any factoring. Okay? We're going to start that on Monday. But what I'm going to do is I'm going to give us a hint instead. So here's my hint. Just like I gave you the hint that I multiplied by 13. I'm going to tell you that x minus 3 is a factor. Okay? By the way, here's a question I want you to think about. This means f of 3 equals what? Don't answer that out loud. Just think about that for a minute. Okay. But I'm going to use the hint in the meantime. So if I know x minus 3 is a factor, just like I knew that 13 was a factor of 221, what can I do? I can do long division. So I don't know, have you guys done this recently? X minus 3 is going to be dividing into 4x to the third minus 8x squared minus 11x minus 3. Wow, we're actually doing, I feel like I'm in 4th grade again, right? At least I did up here. My son's 4th grade teacher last year had like a song. Divide, multiply, subtract, compare, bring down. There's a lot of stuff for them to remember, you know? So they had to sing this while they did it, all right? So we divide. Now when you do this, watch. Don't try to do x minus 3 into the whole thing at once. Just look at the x. And I say x times what would give me 4x cubed? X times what? 4x squared, right? So I'm going to put a 4x squared. I like to line up, kind of like lining up my place values. I'll put the 4x squared there. So that's the dividing step. And then what do? I multiply. So let's do 4x squared times what? What times the x minus 3? Okay? So what do we get? 4x cubed minus 12x squared. Okay? Now I want you to watch this next step. What's the next step after this? Okay, subtract, but this is where I teach it differently. We're in algebra class. I don't like subtracting in algebra. I would much prefer to add the opposite, or add the negative, than I would subtract it. So what I tell people is, hey, when you draw your line, then I change my signs. So this is a negative now, and that's a positive now. And now I'm going to end up adding, because I changed the signs of each of them. Remember, subtraction is actually adding the opposite. I actually find that it's helpful to have a different color here. All right? So I can see exactly, did I change that sign yet or not? All right? So now I add. And when I add, the x cubes go away, which is nice. That's what I wanted. What do I get for the x squareds? 4x squared. And now bring down. Bring down actually the rest of it. No reason not to. Just to help keep everything lined up. Okay? And now we go through the process again. And we say what times x is 4x squared? What would we say? Plus 4x. Okay? And if I multiply this out, I get 4x squared minus 12x. I'm going to speed up a little bit here. when I draw that line, then I change my signs. And I bring down and I get an x minus 3. Oh, look at that. What happens? Plus 1. So I do get a remainder of 0. All right? And that's very nice because now I can write that f of x is actually equal to x minus 3 times what? Well, times this. 4x squared plus 4x plus 1. Okay? Can you factor 4x squared plus 4x plus 1? Good. Again, if you can't, we'll work on that on Monday. So actually, there's a nicer way to write this one. We'll write it now the way that it's written in your book when they give it to you. Oh, by the way, this is called G, not F. I forgot about that. But when your book does this problem, let me show you what they do. They write in number 14, g of x equals 2x plus 1 quantity squared times x minus 3. Now, the first thing it asks me to do is to find the zeros. Well, what do? Once I have it in factored form, I get some separate equations that might be 0, right? Like, I get that x minus 3 might be 0, and so what is one of the zeros? 3. I also get that 2x plus 1 might be equal to 0. So another 0 is negative 1/2, right? Okay. So the last thing I have to show you today is what's called a sign diagram. And this is actually a nice tool we will use again and again and again in this course. But I want to introduce it now. So what I'm going to do is I'm going to plot the point negative 1/2 and 3 on a number line. And the reason I'm putting those is those are my zeros. I know that g of negative 1/2 is 0, and I know that g of 3 is 0. I also know something about a polynomial, and that is it's going to be what's called a continuous function. That means what I really want to know now, guys, is what happens on this side of the 0, on that side of the 0, and that side of the 0. Okay. So give me a number bigger than 3. 4. All right. So let's try 4 as a test point. And so what I'm going to say is, if I do some work down here, let me do it over here. Remember that g of x is this 2x plus 1 squared times x minus 3. So g of 4 I could compute, and I'll get 2 times 4 plus 1 squared times 4 minus 3. The 4 minus 3 is 1. This gives me 9 squared. And so I get that g of 4 is what? 81. But you know all I really care about is that it's positive. And since g of 4 is positive, I know I will be above the x-axis over here. We'll see if that makes sense to you or not. Here, let me try this, guys. G of 0, because that's in between here, and I love doing 0. It's so easy to compute. What is g of 0? Let's see. It would be 2 times 0 plus 1 squared times 0 minus 3. So it's going to be 1 squared times negative 3. Yes, I agree. It's negative 3. But what I care about is not that it's negative 3. I care about the fact that it is negative. And so I am negative in between negative 1/2 and 3. I'm positive here. I'm negative here. Last one. Let's do g of negative 1. So I get 2 times negative 1 plus 1 squared times negative 1 minus 3. Hey guys, I don't even have to compute that. All I care about is if it's positive or... Now take a look. This thing, this piece, is positive because I'm squaring it. When I put a negative 1 in here, it's negative. So positive times negative is what? Negative. So I know that this is negative over here. Okay. Once I have my sign diagram, I can kind of give you a sketch of this. And so I'm going to finish with that, and then we're out of here. The graph goes through negative 1/2 comma 0. It goes through 3 comma 0. It's positive over here, and it's negative in these two intervals. That means here's what it does, guys. Something like that. Something like that. And we'll talk more about it next time. But that's enough to get you started this weekend. I'll see if I can post this online for the non-note takers.